Okay, YouTube, in this video we're just going to run through 3 examples of finding inverse functions, and what I'd like to do is break this down into a process still. So the book presents it one way here that I'm borrowing the screenshots from, but I'd like to break it down into a process where we kind of start by doing this. We're going to switch all x and y. So switch all x's and y's. And essentially what we're doing is we're switching the domain and range. So we're going to write that there. We're going to say switch the domain with the range and vice versa. Okay, so that's what really we're doing here. And then what we're going to do is we're going to solve for y. So considering the instructions here, say solve the function that you're given here for x. What we're really going to do is switch x and y around so that that x becomes a y, and then we're going to solve for that y. So in essence, we are solving for the same thing they're asking us for here. But I'm going to add a third step here. We're going to rewrite this y as this, and we're going to write f inverse of x. And what this really is the undo function, or the backwards function. So if you were to give an output of, say, the original function f of x, give a y value to the inverse function, what it does is it sends it back to the original x value of that original function. So it undoes it. So considering these 3 functions here, let's start with number 1 here. I just want to kind of keep these very straightforward. So we're going to rewrite this as y equals x minus 2. And in order to get the inverse function, I'm going to switch colors, because the moment we switch all of our x's with y's and y's with x's, this is the inverse right here. The idea, though, is that we like to isolate the y value. So we're going to add 2 to both sides. And so we get this. We get y equals x plus 2. And I've kind of switched my sides around here. But what I'm going to do is, in my final step here, I'm going to rewrite this y equals as f inverse of x equals x plus 2. And we can see how these 2 functions are really just backwards in relation to one another. One function, the original function, says, give me what you take as an x value, and I'll subtract 2 off of that. And then I'll take what you give me as an x value, and I'll add 2 to it with my inverse function. So they undo one another here. So looking at number 2 here, let's see if we can find a function that would undo what f of x is doing here. So again, let's start with renaming our f of x as y, and we'll get y equals 2x squared. Now I'm going to go ahead and switch colors here, because already here is our inverse function. So let's go ahead and isolate the y value here, starting by dividing by 2 here. And I'm going to write x over 2, and this is equal to just y squared. So we might as well take the square root of both sides now. And so on the right side we get y equals, on the left side I suppose we would get the square root of x over the square root of 2, and this would be plus or minus, and I do want to rationalize this. I don't want to keep a radical down there. Just as a matter of simplifying, sorry everybody, but we get the square root of 2x on top, and on the bottom we get 2, and this is all plus or minus. I think the idea, though, is that we want to call this f inverse of x now, or we could say that f inverse of x is equal to this right here, this function. And so, and I want to say loosely a function. We would keep only the positives, then we'd have a function. If we keep plus or minus, it's not really a function. But we won't read too much into that right now. What I'd like to do is take a look at number 3, f of x equals negative x cubed plus 3. So again, we're going to call this y equals negative x cubed plus 3. And start by switching our colors, because the inverse then would be x equals negative y cubed plus 3. So again, we just want to isolate the y. So let's go ahead and start by kicking things off this side, starting with the 3 here. So we have x minus 3 equals negative y cubed. I'm going to go ahead and divide by a negative 1 also. And because that's a monomial divisor, I'm going to go ahead and divide every term on the left here by this negative 1. So we get negative x plus 3 is y cubed. And so our final maneuver here, I suppose, is to take the nth root. And so we get the cube root of negative x plus 3. And this is equal to y, or what we're going to call the inverse function of x. And so this is just kind of good practice for how you find the inverse of a function, how you label it. Cheers.